Okay, now let's talk briefly about observables and signals in our application. These are two things that we're going to be using continuously to help us build our application in Angular. And we'll start with observables. These have been around the longest in Angular. They've been available since Angular version 2, and these were, at the time, a new standard for managing asynchronous data included in ECMAScript 7, otherwise known as ES 2016. And as mentioned, they were introduced in Angular 2, and they give us a way to observe or listen to multiple values over time. And you can think of observables like a newsletter. Only subscribers of the newsletter receive the newsletter, and if no one subscribes to the newsletter, it probably will not be printed. So observables are lazy, effectively, and if we want to listen to an observable and get those values over time, then we have to subscribe to them. And if we subscribe to something, then obviously that implies that if we want to stop listening to it, then we need to unsubscribe from it. And in JavaScript, we have the option really to use a promise, which is also used in asynchronous code, or in Angular, then we can use an observable, and we have that choice. And I'm going to talk about a third choice that we have, which is not really to deal with asynchronous code, but something that I'm also going to talk about at the same time in this lesson, which is Angular signals. But if we take a look at promises, then a JavaScript promise provides a single future value. It's a promise that a value will be provided in the future. It's not lazy, so it's always going to return something, either the thing that we're looking for, or it's going to return an error. And we cannot cancel a promise. If we've asked for something, then that's going to be delivered. Even if it's something really big, then it's either going to error or it's going to complete. An observable will emit multiple values over time, so this is very good for streaming data. It is lazy and will do nothing if nobody subscribes to it. We can cancel it. And also we can use other operators to transform the data over time that we're receiving, such as map, filter, reduce, and other operators, and to do that we use a library called RxJS. And if we think about observables in Angular, then typically we're going to be using our HTTP client in an Angular service. That's the appropriate place to use that. And when we make an HTTP request with the Angular HTTP client, then this will always return to us an observable. And then we'll attempt to consume that inside our Angular component. But these code examples here will not actually do anything because nothing is currently subscribing in this example to that observable. Observables are lazy. If nothing is subscribed to it, it will not execute. And also we have the opportunity with RxJS to do something with the values that are returned over time from the observable. We can use a map function to transform or do something with that observable on its way back to us. And we'll use that technique as and when we need it. If we get a member back from our API, if we don't want to return the full member to the component, we could use the map function and return, in this example, just the member ID, if we were only interested in getting the member ID. And in order to use that map function, then we need to use the pipe that we get from RxJS, and then RxJS provides us with operators, things that we can use with our observables that we're getting back from our HTTP request, and then we can map over what we're getting back and then just return, let's say for example, the member ID. Now in order to get data from observables, we have to subscribe to them. Observables are lazy, as I mentioned, so we have to use the subscribe method in order to actually get the data from there. And then we supply the subscribe method with what to do next. What do we do once we have the members? And then we can set a property in our Angular class component. We also can specify what to do if there's an error, and also specify what we want to happen when the observable has completed. Now in the case of an HTTP request, which is what we're looking at here, then HTTP requests always complete. We don't need to worry about unsubscribing when we're using an observable that's returned from an HTTP request, because HTTP requests complete. But in any other circumstances where we're using observables, then we would want to unsubscribe We can also use the toPromise method from an observable if we just want to return it as a simple promise by using the toPromise function. And what we also have available to us is something called the async pipe. And we can use this inside our template. And this will allow us to automatically subscribe and unsubscribe from the observable without us needing to do so in our component code. Now, Angular traditionally has got a reputation from developers as being somewhat tricky to learn because of the nature of observables, because of the RxJS library that we have to use when working with observables. It can be perceived as slightly tricky to learn because of those things. But since Angular 16, Angular introduced something called signals. Now, these are not used with asynchronous operations. We still need to use observables for that. So things like HTTP requests, where we make an HTTP request and then we have to wait for something to come back. Well, that's still going to be using observables, and we'll still continue to use them. But in the previous iteration of this course, we also needed to use observables when we wanted to notify components, other components in our application, when something changes, even if that's not an asynchronous piece of code that we're using. So to address that, Angular introduced signals, and signals, or a signal, is a wrapper around a value that notifies interested consumers when that value changes. And signals can contain any value, from primitives to complex data structures. And if we just take a look at an example of usage of a signal, then we can create a signal using this kind of code. We'll say const count in this example equals signal, and then we give it an initial value. We can also specify the types inside here as well. And signals are getter functions, and calling them reads their value. So if we wanted to get the value of the count, then we effectively execute it with parentheses afterwards. And then we've got a couple of methods that we can use with our signal. We can set the value using the set method of the signal, or we can update the value using that method, and this will give us access to the previous value the signal was set to, and then we could take that value and do whatever we want with it to update the signal's value. Now, any other component where we're using this signal, that component would be notified of that update. And these are brilliant for synchronous code and any kind of state management that we want in our application. We're going to take a look at using this with our current user, our user that signed in, so that our components can be notified if we do have a current user or we do not. So we have the logged in and logged out behavior and can update our user interface accordingly and show logged in users a different view to logged out users. And signals are significantly simpler to use than observables. We do not need to worry about RxJS. We don't need to worry about values over times. These are good for state management, and that's how we're going to use them in our application. And the advantage of signals is their simplicity and readability. Signals provide a more declarative syntax, making our code easier to read and understand. And compared to observables, there's a lot less boilerplate, so it makes it easier to understand them. And they're great for state management, as I mentioned. Also, they're good for performance. They can be more efficient than observables in terms of change detection, as they work by tracking dependencies and only re-evaluating when those dependencies change. And this can lead to less unnecessary updates and therefore better performance. And because we don't need to worry about subscribing or unsubscribing, then these are automatically cleaned up when they're no longer in use, which means less risk of memory leaks common with observables if we'd forget to unsubscribe from them. They also offer us predictability because they're updated synchronously. This gives us predictable state changes in our application. And they're also well integrated with Angular components. And we don't need to use any additional libraries like RxJS or complex operators to use them in our code. So we're going to use these a lot for the rest of our application because they are so much better to use for the kind of things that I used observable for in the previous iteration of this course where in order to notify a component of a change, then observables really were our only choice, but signals give us a much better experience when developing our code. We still need to use observables when we're dealing with asynchronous code, but when it's state management, then for all of those situations, I'll be utilizing signals. And we'll take a look next at using this with our current user or our logged in user.